All right, let's try another example using our natural logarithmic form. This time one that's not polynomial or EDX related. Let's try one that has a trigonometric function like cotangent and cosecant squared x. Again, we can make the replacement fairly directly right here if we recognize that if we set u equal to the cotangent of x, the derivative of cotangent of x, so du, will be cosecant squared x dx, which we have directly in this expression. We end up with an expression that looks like the antiderivative of du over u. So, not very hard. We've got our natural log of the absolute value of u plus c. And if we make the replacement in the right place, of course, we see that we have the natural log of the absolute value of cotangent of x plus c. And the absolute value brackets are required right here because cotangent of x itself could be a positive or negative expression, but within its domain we would say cotangent of x, we want to always have a positive value in that natural logarithm. Okay, well that example actually wasn't too bad. Let's try another one. Only this time it seems like it might be a little bit harder because it's maybe not exactly obvious what to do right here. But we might note, we could try to say u is equal to x to the 1/3, right? Because we see that cube root down there. And that's tempting, except that would imply that we would get a derivative of u equal to, let's see, what would we get? We'd get 3 halves x to the, not 3 halves, 3/4. My apologies here. Let me make the correction right there. 3/4 of x to the 4/3. Wait a minute, that's the integral. Well, I'm having a good day. Our derivative right there would end up being what? 1/3 x to the negative 2/3 dx. And what's the problem with that? Well, we've got x to the positive 2/3. Well, clearly I was confusing myself. That's not going to work at all, right? We need another option. So let's try the other one. In this case, let's take u equal to x to the 2/3 minus 1 and see what happens there. Well, if we take our derivative du, we end up with 2/3 x to the negative 1/3 dx. And well, just a little bit of rewriting is going to give us something like this, that 3 halves times du would equal dx over x to the 1/3. So now we might see that this dx over the cube root of x is in fact du right there. And so we actually do have an arrangement where we have, if I were to rewrite this again, we've got our integral of x to the negative 1/3, if I wanted to rewrite it here in place, dx, divided by our quantity x to the 2/3 minus 1. And making the substitutions right here, that means we've got 3 halves, the antiderivative of du over u, which of course we know is our natural logarithm. So we've got the natural logarithm of the absolute value of u plus c. Don't forget our fraction 3 halves comes along for the ride right here. So making the proper replacements in the proper place is going to give us our integral, which is going to be the antiderivative 3 halves times the natural logarithm of the absolute value of x to the 2/3 minus 1 plus the constant c. And that's what we were looking for. Now we're done. Now we can go on with our happy day.